For this question, we have a monochromatic light shining on the cathode. Electrons are emitted going to the anode, so as shown in the diagram. And we have the photoelectric effect IV graph also given. So question asks, right, which of the following cannot be deduced from the graph? Okay. Let's look at option A. Intensity does not affect the maximum KE. Can this be deduced? Well, it could, because right, we have two different intensity. Both of them right have the same stopping potential. Okay. So stopping potential right is an indication of KE max. Therefore right, we can see that both intensity has the same KE max because the stopping potential is the same. So it can be deduced from the graph. Intensity is proportional to the current. Okay, so this is actually the statement that cannot be deduced. Why so? Because right, the idea of proportional is talking about a linear relationship between two variables. Yeah. So when you say y is proportional to x, we are saying right, when x doubles, okay, y doubles. But we can't see that from this graph. We only know that when intensity increases, saturation current increases, but there's no quantitative indication. So this statement right could not be deduced because we can't tell that it's proportional. And this is actually right the option that most people miss out. They thought that this is a correct statement, but it's actually not deducible from the graph. It's actually accurate. Okay, we actually know that it's proportional, but it just cannot be deduced. Next up, right, photoelectrons are emitted at a slower rate for B. Okay, that can be deduced because right, the current is equals to number of electron per unit time times the charge per electron. So you can see that indeed right, B has less electrons emitted at per unit time, so emitted at a slower rate. Lastly, right, this is the most common option that people chose. Electrons ejected with different KE. Can it be deduced? Well, we could, because right, just look at this slope here, especially this portion. Why is it that when we make the potential difference more and more negative, you see, what does this potential difference mean? It's saying right, is the potential of this V right is actually equals to VC minus VA. Okay, when VC equal minus VA right is negative, it means right we are making C negative compared to A. Yeah, lower potential. So it's making it hard for the electrons right to get over to the collector plate. A simple analogy right would be, suppose you roll a ball up this slope, or you gave it some KE, and in fact you roll many balls up this slope. Some has more, some has less. Yeah, and as you make this height of the slope higher and higher, some of these balls right which have less and less KE right, or not enough KE, they will not get to the top of the slope. Those with more KE will still manage to get to the top of the slope, but there will be some height right whereby you raise it higher to such that right even the most energetic ball can't reach the top. Yeah, so that is the same for this setup. We are trying to make it hard for the electrons to reach collector plate, and you can see right, as you make it harder and harder, the current right drops. That means right, fewer and fewer electrons make it through, and that will means that they must have different KE in the first place. Yeah, so option D can also be deduced from the graph.